Wow, we've got lots of stuff going on, including a Earth-directed coronal mass ejection. New sunspot rising. It's a return of an old sunspot. I believe it's 2860. Coronal mass ejections. I mean, what more could you possibly want, folks? Here's some SDO imagery, and keep your eye on the southern hemisphere. Lots of things going on down there. Also, a bunch of coronal holes rotating into the Earth-facing zone. It may seem inactive, but the star is less than inactive. It's more active than inactive. It isn't inactive. Anyway, that's my point. We were recently at over 120 sunspots. And now we've got a bunch of filamentary activity here. Again, some Earth-facing coronal mass ejections. We'll be looking into that further. We don't even have the full data yet, but here is this sunspot rising in the southeast. I think it's 2871 is going to be the name of this one. Here it is in two wavelengths, 1600 and 1700 angstroms, ionized carbon and extreme UV. Pretty big sunspot. It's about the size of the Earth, and it is a beta class sunspot. The radio flux is, I think, now at 74. Here's the 1-year chart of the radio flux. The black line is the radio flux. And we just saw Space Weather Enthusiast dashboard update. So radio flux at 74. We don't see any modeling yet of this series of coronal mass ejections. We'll show you a little bit more analysis in a minute. Let's check out the seismic uptick that's been happening. A little bit of an uptick here in global earthquake activity. Let's just go up the list. No major quakes, just a general uptick here. For example, El Salvador saw a 5.0. Also, we see some Southern California quakes. Shout out to our viewers in those locations. Here's a 5.3 at Papua New Guinea. That's one of the largest. Also a 5.0, not far from that 5.3. Here's another decent-sized quake. It's a 5.2 at depth. A depth of just over 200 kilometers estimated for that 5.2 near Tonga. Vanuatu saw a 5.1. Some quakes in places like Idaho. And Japan saw a 5.2. So a minor uptick here in earthquakes over the past 24. Volcanoes, I'm seeing this for the first time myself. Explosive activity from Kamchatka has produced a 14,000-foot ash plume. Sakurajima now back on the list, 7,000-foot ash plume over the area around Kyushu, the Isle of Kyushu, Japan. Suminosejima exploding, 6,000-foot ash plume over the Ryukyu Islands. Fuego exploding, 15,000-foot ash plume over Guatemala. Revenador exploding, 16,000-foot ash plume over Ecuador. And intermittent emissions from Sabancaya are a reminder to not pole vault the caldera and to join the Smash team at smashamash.com/Smash team. For all of you folks who refuse to pick up some merch, you can find links to that at smashamash.com. Our insane merch shop. Yeah, your vaccination status is none of my business either. Take a look at the GOES magnetometers here, and we see some sawtooth spikes as there's been some plasma showing up in the form of a coronal hole wind stream. Now, some folks are saying that there's a CME that's been striking, and frankly, I don't see a signal. Again, I won't harp on it. I didn't harp on it yesterday, but let's just press refresh and see if it's going to show us both magnetometers. It's only showing us the GOES 16. Anyway, let's take a look at the heliospheric current sheet. Earth is solidly in a south pole current sheet. There's the latest image, south pole current sheet shown here in red. North Pole in green. Pardon my sloppy penmanship. Here's a line of sight view of the same data here. And there is a North Pole current sheet on the way. It may show up more quickly than we expect. Keep in mind this data's nearly an hour old. And this was a recorded video, not a live stream. So here's a line of sight coronal hole plot. This data nearly 2 hours old. And a massive series of coronal holes showing up here in the southeast, ahead of that sunspot. I believe it's 2871. Correct me if I'm wrong. And here's a view of the sunspot, of the both the sunspots and the coronal holes. And one of the coronal mass ejections came out right out of that area right there. And we'll show you some great close-ups of that at the end of the video. We're just showing these wavelengths. This is 211 and 193 angstroms from the SDO. These are great at showing the depth. What evil lurks in a coronal hole? High-speed protons are coming out of that coronal hole. So here is the view from Lagrange point 5. We're looking at stereo A's coronagraph and the difference imagery. And we can see some of this ejecta right here. And while there is missing data, the difference imagery is showing through. And you can see that that is indeed on the Earth line in terms of north and south. So on this axis, that is lined up with the Earth. We'll show you where it shows up on the SOHO spacecraft at the end of the video. So we've brought up the 7-day X-ray flux here. And for some reason, we're seeing missing data. Let me see if I can refresh that. And there we go. There's the 3-day X-ray flux. You can see a couple of C-class flares here, 3 of them in the past 3 days. The possibility of flares is once again back. And while that new sunspot, really it's a return of an old sunspot, while that is not super active at the moment, it is capable of producing some flares. So it is a beta class sunspot. We do see 2 polarities, and we'll show you that later in the video. No spikes in the proton flux, so at least the most recent activity has not sent any relativistic particles to the Earth geospace. We'll take a look at the real-time solar wind, which has been pretty uneventful here over the past 24. We see a waning of a coronal hole wind stream. Current conditions are 324 kilometers per second for the speed. Solar wind density 9.2 protons per cubic centimeter. Otherwise, fairly unremarkable solar wind. So here's the KP index, and you can see that geomagnetic storm late in the day on the 17th. Brief period of geomagnetic unrest yesterday, and very calm since then. It's the calm before the CME arrives. You can expect about 3 more days before any of that ejecta arrives at Earth. Here's what's going on currently in the geospace. Very low pressure. Low pressure in the magnetosphere. This is 4 hours of data modeled by the Space Weather Modeling Framework. We show it daily on the channel. If you want to see what was happening around this time of day on a previous day, go watch one of our old videos. We've got over 800 daily space weather videos in the playlist. Here's Geospace Delta B. The last one was the view from space. This is the view from ground. And this is in nanotesla. We don't see many changes to Earth's B field, otherwise known as Geospace Delta B, happening at the moment. With such a steady and basic, uninteresting solar wind at the moment. You never know where the activity is going to come from, folks. You may be surprised. Next, we're at theplanetstoday.com to show you a chart of the solar system. Here's where stuff is now. We'll advance it a week. Full moon coming up in a couple days, as well as our equinox stream. The equinox happens at about 3:20 on Wednesday. We'll be streaming live at the moment of that. Make sure you join us there. It'll be a YouTube exclusive. Here's a star chart from in-the-sky.org. We've got the ecliptic, the yellow line, and the galactic plane, the blue line, drawn in here to show you where stuff is above my head. We're located in Lehigh Valley, Pennsylvania. Today's cosmology segment is going to be really brief. If you didn't watch this cosmology segment, make sure you check it out in our playlists, youtube.com/smashamash/playlists. Over 200 videos in our cosmology segments. Did you know that Saturn has phases? Yeah, the rings look differently depending on what time of year it is. The orientation between the sun and Saturn versus the Earth. Saturn has phases, folks. And the rings look differently. So that's the astronomy picture of the day today, apod.nasa.gov. That's today's cosmology segment. We're making it brief because there's lots of things to do that we'll perhaps talk about at a later time. Next, looking at charging hazards. We don't see any satellite charging hazards at the moment. That's a good thing. Relativistic electrons are in a moderate range at the moment. There's a 1-year chart from Solon.info. And let's see if we can refresh this data. And at least we've got the GOES 16 there. Looking like a pretty moderate range here, like the normal subsiding that you would see after about 3 days of a coronal hole wind stream. So here's the relativistic electrons in the forecast model. The green boxes are the forecasts. We're expecting an uptick here in the next 2 days. And indeed, that could have some sort of an effect on the incoming coronal mass ejection strike. Here's a diagram of the Van Allen belts because we're going to show you the total electron content forecast next, which is the electrons between approximately here where your GPS satellite is located and your handset at ground level. Hence the term total electron content. GPS errors usually occur around the equator at noon, and when they get chaotic, this will show you the chaos going on in the electron belts. Things looking pretty normal here, like they're going to return back to like they're just in normal bands at the moment. Nothing to write home about there with the electron flux. What's really to write home about is the incoming solar ejecta, known as a coronal mass ejection, where charged particles, primarily hydrogen nuclei, show up at the geospace, causing radiation and all kinds of other effects, like the aurora borealis. Here's a diagram of the atmosphere showing you where the F ionosphere layer is located at about 300 kilometers of altitude. And here is the ionogram. And we're seeing some significant anomalies here around places like Southeast Asia. Some very large swings between high and low frequency anomalies we'll show you on the next map. So yeah, some ionospheric anomalies going on at the moment, folks. And the next map will show you better if you're not used to looking at this. We now show the anomaly map every day. This is the departure from the 30-day median in megahertz, and you can see low-frequency anomalies here along the equator, and high-frequency anomalies making a huge disparity in the vibrational frequency there in the ionosphere. Check out this weird ridge. There's a low-frequency ridge that forms right there where my circle is. Low-frequency anomalies over Europe and the Atlantic Ocean. High-frequency anomalies over the northern Indian Ocean region. So quite a bit of anomalies showing up here. Here's the latest image. Things looking normal at that moment, though. There's 10 o'clock Universal Time. Once again, we've put up another awesome meteorology segment. Make sure you check that out if you haven't. Thanks to our BitChute subscribers. If you haven't seen our latest BitChute exclusive, it's actually this one here, a stream. You also may have missed this one, which came out on the September 11th. Never forget to demand accountability. We're also on Twitch. We're regularly streaming and doing it more and more now thanks to our followers over there on Twitch. They've got a great app that'll tell you when we go live, like we did when we did our meteorology segment. We also regularly stream live to YouTube. However, at the moment, this is actually a recorded video. Congratulations on realizing that we exist. Before we vanish, make sure you press like, subscribe, share with your friends and foes, science noobs and science pros. Thanks to our patrons. Thanks to the Smash team. You can find links to it at smAsho.com. If you haven't checked it out yet, smAsho.com/Smash team. Again, links on the homepage. And yeah, there's an Earth-directed CME on the way, folks. We can expect to see the arrival of that in a little over 3 days. And we're showing you what goes on at the Smash team. So depending on what level you're at, you may see a different view here. If you're at the gold level, you'll see all the posts. There's also a silver level and a bronze level, which is free, so check it out. We're giving you insight nobody else gets to see. It's only in these videos or by being a member of the website. So again, at the homepage, check it out. Also check out our merch link. Here comes some bonus features in the form of the El Teide ground-based solar observatory located in Spain. We've actually relaxed our coronal mass ejection warning. We're not expecting any other coronal mass ejections in the near future, but the likelihood of solar flares has gone up. And there indeed still are some filaments. So make sure you stay tuned to the channel. We'll be looking at this on the regs. Here is the latest intensitygram and solar magnetogram. So here's the close-up of this new Sunspot 2871, I believe it is. You can see that it is beta class. So at least 2 polarity umbrae there. You can see this umbra right here is North Pole oriented. So there is a small umbra that's just enough to make it a beta class sunspot. I believe the rest of that is just South Pole polarity. So this is capable of producing major flares, believe it or not. Here's the view from Lagrange point 5. Not Lagrange 5, Lagrange point 1. My mistake. Lagrange point 1. So here's the view from Lagrange point 1. The LASCO C3 on the left and the LASCO C2 on the right. And you can see some of this ejecta appears to be Earth-directed. You can see sort of a halo, sort of a formation happening there. And while there were two distinct CMEs, at least one of these includes Earth-directed ejecta. So it's not a classic halo ejection, but this is not far side of the sun ejecta. This is Earth-directed. So let's close things out with some more views here of the closest star. Here's the southern hemisphere. A great view of this coronal hole in 211 and 193 angstroms, both ionized iron spectra. You can see there are still some filaments hanging out up there, but we've reduced our coronal mass ejection watch to nothing. Solar flare watch has gone up, though. So there is a solar flare watch. We could see some additional activity here. But yeah, we've relaxed the coronal mass ejection watch. Here are some even better views, by the way. All eyes on the southern hemisphere here in this 304 angstroms animation. You'll see some of the ejecta, which actually ended up way on the west side as it exited. It got slingshotted by magnetic fields, if I had to guess. And if you've got theories as to how the sun does what it does, by all means, leave them in the comments. It's an interesting time for things like astrophysics. So here's a close-up of all this filamentary activity. Quite spectacular indeed. Once again, congratulations on realizing our channel exists. And I believe we've got one more close-up here for you. But I stand corrected. That's all she wrote. Anyway, thanks again for tuning in. Talk to you soon. May that solar wind be at your back.